Good day, guys. Yeah, welcome back to our channel, Aliphatic Teaches. Today's class is going to be the gas law under the chemistry. But before we venture into the subtopic, if you are a new member on this channel, kindly click the subscribe button and click the notification bell. Boyle's law. Before we now venture into the Boyle's law, let's talk about the factors affecting the behavior of gases. The following factors affecting the behavior of gases are termed into MPVT, where N stands for the amount of gases, that the number of moles of gases, P stands for the pressure of gases, V stands for the volume of the gas, while the T stands for the temperature of the gas. Now, let's look at gas pressure. When we look at this container, it contains some amount of gases. These particles of gases are in continual motion, thereby colliding with one another and also colliding with the wall of the container. As they are colliding with the wall of the container, they exert a pressure called the gas pressure. Now, what does Boyle's states? Boyle's law was formulated by Robert Boyle, a scientist, in 1662. Boyle's law states that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature and the amount of gases remain constants. Now, let's look at the experimental representation of Boyle's law. Now, look at these two containers containing equal amounts of gases, but at a constant temperature. When we look at this lid here, the piston here, the volume, if the volume of the gas here, is at 15 centimeter cube, and we assume the pressure is at 1 atmosphere. Here, we have a larger space for the amount of the number of particles of gases when the pressure is 1 atmosphere. When you press down or you increase this lid, this piston, when you increase the load and push down the piston down to half of this, we find out that the volume here decreases, let's say, to 7.5 centimeter cube, while the pressure will increase to 2 atmosphere. This is what Boyle's law is stating, that when you increase the volume of the gas in the container, the pressure will be reduced. Conversely, when you decrease the volume, the pressure will be high. So here, there are larger space here for these gas particles to collide more effectively with each other, thereby increasing the volume and the pressure is reduced. Here, there is a smaller space for these gas particles to collide with one another. In that case, collision here is very, very high compared to this part 1. So the collision here is very high. Definitely, the pressure is also what? High. Now, according to Boyle's law, which states the volume of a given mass of gas is inversely proportional to its pressure. When we say inverse, it means 1 over P. That's inversely proportional to its pressure. Now, when we remove this proportionality, we have volume is equals to K over P. When you cross multiply, we have K equals to PV. So this is K equals to PV. Okay. According to what we did in the experimental level, let us move back to our experimental representation of Boyle's law. Here, our volume, let's say V1 now, is equals to 15 centimeter cube when our pressure remains 1 atmosphere. At this point, when the piston is being reduced, the volume is reduced to V2, which is 7.5 centimeter cube, while our P2 equals to 2 atmosphere. Fine. According to this formula, K is equals to PV. Our pressure here, let's say P1 V1, we have 1 multiplied by 15, which gives us 15. Our constant is 15. At this point, K equals to P2 V2, which is equals to P2 is 2 multiplied by 7.5 equals to 15. Then, in this case, K equals to 15 here, K equals to 15 over there, which means that when you modernize this, we are going to have P1 V1 is equals to P2 V2. So the P1 V1 equals to P2 V2 is a constant. Now let's talk about the graphical representation of Boyle's law. Let us consider this graph. V, that is volume on the vertical axis, the y-axis, and the P on the horizontal axis. Considering this container A, B, C, when our volume is 15 centimeter cube, pressure is 1 atm, 15 centimeter cube. Our pressure is 1 atm. When the volume is 7.5 centimeter cube, as it is here, our pressure is 2. When the volume is 4 centimeter cube, our pressure is 3. So we have our curve this way. So this is the graphical representation of Boyle's law. Let's look again at the formula of Boyle's law. P1 V1 equals to P2 V2, where P refers to the pressure and the SI unit of pressure is in Newton per meter square, and also it can be expressed in millimeter of mercury or in atmosphere, as we have seen before. You see, for pressure, 1 atmosphere is equals to 760 millimeter of mercury, and in turn equals to 1.01 multiplied by 10 raised to the power 5 Newton per meter square. So this is the unit of pressure, while volume is measured in cubic centimeter or cubic meter or cubic decimeter or liter, which means for volume, 1 decimeter cube is equals to 1000 centimeter cube, which also equals to 1 liter. So 1 decimeter cube equals to 1000 centimeter cube equals to 1 liter. In turn, also equals to 1 meter cube. So these are the units of volume and pressure, which can now be used in calculation during our numerical values. Example 1. A sample of nitrogen occupies a volume of 0.60 dm cube at 400 Kelvin and atmospheric pressure. What will be its volume at 400 Kelvin and 507 millimeter of mercury? Given that 1 atmosphere equals to 760 millimeter of mercury, let us interpret this. A sample of nitrogen occupies a volume V1 of 0.60 dm cube at 400 Kelvin. Our T1 temperature is 400 Kelvin, and atmospheric pressure, we are not told the atmospheric pressure. What will be its volume at 400 Kelvin? Another volume means V2 is unknown, and 507 millimeter of mercury. So anything in millimeter of mercury as we've learned is pressure. P2, 507 millimeter of mercury. If we recall, they mentioned at atmospheric pressure here, and the value was not given. But here now they said 1 atmospheric pressure equals to 760 millimeter of mercury, which means P1 is 1 atm, which has the value of 760 millimeter of mercury. Looking at this again, they said this second temperature here, what will be its volume at 400 Kelvin? Another temperature, 400 Kelvin. Here, the temperature T1 and T2 are equal. When we have a constant temperature, it means Boyle's law will be applied. That is, P1 V1 is equals to P2 V2. We are told to find V2. Our V2 will equal to P1 V1 divided by P2. When you insert the value, our V2 will equals to our P1 here is 760 multiplied by our V1 is 0.60 divided by our P2 is 407. So when you multiply and divide, we have the value 0.9 dm cube. So it's in dm cube because our V1 as well also is in dm cube. Example 2. The ratio of the initial to the final pressure of a given mass of gas is 1 to 1.5. The ratio to the final pressure is 1 to 1.5. Calculate the final volume if the initial volume was 300 centimeter cube. Here, our pressure P1 equals to 1 unit. Our P2 equals to 1.5 units. Calculate the final volume. V2 is the final volume, unknown. If the initial volume, which is V1, equals to 300 centimeter cube. From here, from our formula that says P1 V1 is equals to P2 V2. Want to calculate our V2? V2 will equals to P1 V1 divided by P2. Our P1 is 1 unit multiplied by our V1 is 300 divided by our P2 is 1.5. So when you multiply this and divide, we have the value 200 centimeter cube. So because our V1 is in centimeter cube, definitely our V2 will also be found in centimeter cube. This is how to apply the formula for calculating Boyle's law. Don't forget, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent classes. And do not forget to share to your loved one in order to benefit immensely on this. You can also lay your hand on the assignments on the board.